So if you have any questions, ask them in the chat, and we can go back at break time. And they're very good about dealing with these in real time, so it's really good. So if you have questions, ask. Oh, this is the geocoding thing, huh? Interesting. Okay, I'll have to look at that later. 19. Okay. Very good. Yes, good. Somebody who's going to be later, so that's good. Or do you find Git on your Mac? You probably need to install it. I think there's a GitHub desktop for Mac. That's a good one. But if you're trying to use it through RStudio on Mac, I'd have to check it out. I don't have a Mac locally, so I'd have to check it out. Okay, so I'm going to go ahead and get rolling because it's 6:05 and I got a lot to talk about. So we got a few minutes for Q&A before we get started. So if there are questions that people have, either that they thought about after last night or that are burning a hole in your pocket right now, I'm more than happy to answer any questions or try to answer questions that people have right now. Nothing, we good? We'll have more time for plotting stuff. That's fantastic. Okay, so welcome back, everybody. Tonight's the second night of our boot camp for our incoming grad students. We're going to keep talking about R. Specifically, we're going to learn some really useful things today. There is, I sent out all the notes. Is there somebody that doesn't have the notes? Because I can put the notes in the chat. Let me go ahead and do that. Okay, so the notes are in the chat if you don't have them already. So since we got a few minutes, because we're doing, we're still technically in Q&A time, this may be a good thing to do before you get started today. If you installed the Tidyverse yesterday, like we talked about, then you should be fine following along. If you want, you can copy and paste this script into R, and it will install several packages that we'll use tonight. If you want to follow along in real time, I would recommend doing that. If you want to go back later and do this at your own pace, that's fine too. But if you installed Tidyverse last night, then you should be fine. Okay, so I'm not going to run that because it takes a few minutes. Okay, so I showed you this last night. This is a little R script that installs a few packages for you that are really useful. I'll show you what those are real quick. Our courses. No, it's our code. Code. It's this guy here. So this installs a few packages. CTV. We'll talk about this towards the end of tonight. Dev tools, Tidyverse, Tidycensus, and knitr. These are useful packages that everything we'll be doing tonight is in this Tidyverse. package though. Actually, let me edit that because we need Ggplot in there too. Okay, so that'll be okay. So this will also install some dependencies, so packages that other R packages depend on. I had a comment in the feedback section from last night about R packages. So I didn't talk about R packages very much, other than that there's a whole lot of them and that they contain code to do specialized types of analysis, things like that. We can talk about that later on in terms of some useful packages I recommend you use. So we can talk about that towards the end of class because I've got useful packages down towards tonight's notes. Data for today, we're going to be using a single data set tonight, and we're actually going to be basically looking at the data set in lots of different ways tonight. First, we're going to go through graphically and do lots of different plotting of the data. And then we'll go and then we'll have a break, and then we'll go and do several different numeric summaries of the data using a different suite of functions. So what we're starting off tonight with is something called packages from the tidyverse. Tidyverse is, here, I'll show you. Tidyverse. Tidyverse is a suite of packages that a guy named Hadley Wickham, who, some of you have this book, I know already, others of you don't, R for Data Science. This is a really, really good book. You can, if you Google it, you can get the whole book for free online, or you can, it's much more advanced than the paper copy is. He's added a lot of material to it since publishing this. Guy named Hadley Wickham, who's a statistician, used to be at Rice, I think. I think he's Australian or Kiwi or from New Zealand. Either from New Zealand or Australia. He was at Rice, I think, for several years, and now he's the head statistician, sort of head circus director at our studio. So he's really, he wrote Ggplot. He wrote a lot of the major packages that people are using for modern computing with R. And the tidyverse is sort of the overarching package that governs all these. And it's lots of different packages rolled into one. So it's really easy to install. And so it does lots of different things, mostly along data manipulation, graphing, reshaping data, reading in weird data, dealing with strings, distributed computing. It does a lot of fun stuff. So we're going to be working with parts of it tonight, and I give the citations here for it. If you haven't done so, if you just run install.packages tidyverse in your R session, then that will install this core component set of packages that we'll be using tonight. Two packages we're going to be using tonight. Big ones are Ggplot 2, which Wickham describes in a 2016 book. It's at the office. It's Hadley's, what he calls the grammar of graphics. So putting together figures like you would a sentence. Or things like that, where you add different components to the graph to make the sentence fancier. Okay, so the same thing works with graphics. As you add more and more grammar, more grammatical elements to it, you end up with more and more complicated picture. So we will be using that, and the other package we'll be using tonight is called dplyr. It's a package to do data manipulation, data summaries, lots of wonderful tools in that. And we won't cover the whole thing. We won't cover all of either one of these, but my goal for tonight is to show you some basic structures that when it comes time, when you're in the stats class, and I would strongly encourage you all to pick up, if you don't want to pick up a copy of this, go to the website for it and get the free version. It's absolutely worth your while to work your way through the exercises in it. It's a really wonderful text, and yeah, I highly recommend it. So yeah, I've got a link for it right here in the notes, so you can link right to it. It's got the entire book. You know, working through just the exploration phase alone is really wonderful, and it'll track pretty cleanly with what I'm doing tonight in what I'm trying to do show you in my notes. Okay, so there's that. Okay, so we load up the tidyverse and it loads up several packages here. It tells you which packages are loading here: Ggplot, Tibble, tidyr, per, dplyr, stringr, and forcats. These are all the core components of the tidyverse. And again, like we mentioned last night, it throws a few conflicts at you. So it's like, okay, well, this version of the filter function is going to take precedence over the base filter function, and the same thing for the lag function. So again, we talked about this last night. If you wanted to use a specific packages version of a function, this double colon thing here, Lily asked that question last night. So any questions before we get started? Okay, so we're going to start out with Ggplot. And if you want, like towards the end, or even after we're done tonight, I can show you sort of how this whole thing fits into an actual research workflow. Like I mentioned last night, Rogelio and I have been working on this publication on socioeconomic unemployment, joblessness during COVID. And so this whole thing is built as a series of this type of workflow where I have dplyr working with Ggplot seamlessly in one single piece of code. And if you all want to see something like that, I'm happy to share. We can happy to work through that at the end of the class. Okay, it's sort of a teaser for a more realistic workflow. So Ggplot in itself has, so we're going to be working with the PRB data graphically here. Ggplot has a few core statements to it. And the Ggplot statement itself, it tells R to establish what the basic data that will be plotted is. So if you think about the X and Y axis of a graph, what variable do you want to be on X? What variable do you want to be on Y? You can use the Ggplot function itself to sort of establish the basic data set that you're going to be working with, okay? Then within that as well, you can define what is known as the aesthetic. The aesthetic is where you tell R, this part of the data is going here, this part of the data is going to be here. So you can, again, establish what's going to be on different axes, what do you want to be, what do you want different colors to represent, what do you want different symbols to represent. This is defined in this aesthetic function. That's what the AES function is. And you'll see this thrown around a lot. Once you use the basic Ggplot function and the aesthetic to define sort of the data set you're using and the variables you're going to be plotting, then the second step that every Ggplot sort of process uses is where you define the geometries. So in Ggplot, there's lots of different geometries. You can think about, well, bars are one, columns, dots, maps. Sam was talking about making maps earlier. You can make a map in Ggplot. There's probably about 20 different geometry types in Ggplot that you can use to make different looking graphs, okay? And you know, some you know, the sort of the art of data visualization is picking the right geometry for the right data that you want, for the right summary of the data that you want to show, right? Some geometries are better to show some things than other things are. And so tonight we're going to walk through, it's not an entire laundry list of all the graphics that Ggplot will do, because I'm not going to talk about maps at all tonight. You spend an entire semester with me in the GIS class learning how to make maps. But we will work with several other geometries that Ggplot does. So the first step is use the Ggplot function, define the aesthetic, define the geometry, how you're going to plot things. And then the third step is you do any annotations that you want. You know, if you wanted to do a basic plot with no labels on any of the axes, you can do that. But again, nobody's going to know what you're plotting. Okay, so to to best convey the information that you're trying to show, you really need to have good annotations about what the colors represent. So a legend, what the lines represent, what the bars represent, what the X and Y axis represents. So, you know, this is where you're going to be adding those extra details to the plot, where the plot can then stand alone by itself. A really good plot is like a really good summary table. It should be able to stand alone by itself without any text explaining what's going on here, okay? And as you're making plots, you know, as you're moving through your coursework and getting into your independent research, as you start making more and more plots, these plots should be exactly that. If you can't give it to somebody and somebody tell you what it's showing, then there's a problem, okay? A good graphic should highlight without any text explanation what you want it to show. So these are the three core components of any ggplot function that you're going to run. And then we're going to try to do a few different things. So first thing you do before you use ggplot is you load the library. And the first thing we're going to be doing is we're going to jump right into a plot. But before I actually get into the code, I want to sort of walk you through what each line is going to be doing. Okay. And again, I want to do this because I want to match up what I'm telling you with these three steps. Okay. So we have basically three different lines of code here. The first line is a ggplot line. Again, ggplot function here, following our 1, 2, 3. Okay. ggplot, we define what the data are. So this is the name of our data set that we've loaded in. Okay. Where did I do that? Did I show you where did I do that? Yes. We load our data right here. We load it from my GitHub site, just like we did last night. It reads it right off the web. You don't have to have a local file. So that's okay. So the data live in our R session here. You can see it in the environment. You can cruise around it if you want. So we know it's there. So the first line is our ggplot line. And it's loading it's telling R what data set to use, the mapping that we want to use. This is how we set the aesthetic. So we're going to tell R which variables in the data set do we want to be involved in the plot. Okay. So in this situation, we're only going to be making a histogram of the GDP per capita. Okay. So the aesthetic we define here is only in this situation only has one variable involved, because it's a histogram. Histogram just shows the distribution of a single variable. So the x-axis is going to be measuring the GDP. So the values that move along the x-axis are going to go from low to high GDP per capita. Okay, so that's what the first line is going to be doing. And then we include a plus at the end of it. That tells R that we're going to add more things to it. Okay, so we use ggplot to define the data and the aesthetic. Then we're going to add something else. The next thing we got to add is the geometry. So what type of geometry do we want to use to plot the data? So if you're doing a histogram, there's a geometry for that, a geom histogram. Okay, just a bit bigger. Tells R this function here. We don't have to put anything inside of it. This tells R that the geometry that we're using is a histogram, and we have another plus at the end of that. So the next thing we're going to add are a plot annotations, and this is the workflow that every ggplot you'll ever do follows. Data, geometry, annotations, every single time. So and so the annotations we're going to add here I'm going to use the ggtitle function. Okay, and there's 5 different ways to do this. Okay, there's always more than one way to do everything in R. I'm going to use the ggtitle function to give the plot a label. Okay, so this is going to give like a big title at the top of it, again, to show the reader what I'm actually trying to plot. Okay, because if I didn't give him a label, I didn't label my axes or things like that, you would look at this plot and say, yeah, it's a nice looking plot, but what is it showing? Nobody would know. So this tells R that the primary title for the plot, so it's describing what's being plotted. Okay, and I do not have a plus at the end of this because this is the end of my 1, 2, 3 steps, and now we're going to see it in action. Oh, I could add another where I label the x-axis using GDP per capita again. So it's not just these numbers that are showing here, but I'm actually giving it a label to tell you, the reader, what you're looking at. So here's what it looks like. Here is what it looks like all together. Library statement. Again, I only have to load this. I only have to do this once per every R session, right? My Ggplot step, and I broke it up over 2 lines, so it's more easily readable. Okay. Sometimes you'll see people do this where they will. Let me scroll down. Yeah. So sometimes you'll see people do this where they just do one big line of code with no breaks in it. So I can do this. I can do all this in a single line of code here. It all runs together. It looks like crap. And it's really difficult for you, the reader, to disentangle what it is I'm doing. It's one big single line of code, and it's just really ugly. Whenever you write code, you have to be aware that you're probably not the only person that's going to be reading it, and you need to write code that's legible. So doing simple things like breaking up a multi-function statement over multiple lines, you're doing your reader a big favor by doing that. And even, breaking up single functions at comma points into multiple lines. Again, this makes it more legible for the people that are reading it. So again, here's our ggplot function and our aesthetic, defining the variable it's going to be plotted. Here's our geometry. And here are our plot annotations that give it a title and a label for the x-axis. All these things are chained together by pluses. So I can put my cursor anywhere in this code, hit Control Enter like we learned last night, and I get my plot. Okay, I don't have to highlight the whole thing. Don't have to do that. I can put my cursor anywhere in the code and it runs just fine. Okay, and I get my nice plot here showing the frequency histogram of GDP per capita in world countries in 2018. Okay, so you see that there's a lot of countries in the world that have very low GDPs and very few that have very, very high GDPs. But I'm looking at this, and does anybody see anything on this plot that they don't like? Be brutally honest. Scott, you see anything you don't like?
The x-axis.
X-axis. What didn't you like about the x-axis?
It's not easily interpretable.
Yeah, what is that? This is scientific notation, okay? This is something that R does when it sees a really, really big number or a really, really small number, it'll kick into scientific notation. So if it's like 1,000,000, it'll do 1e to the 6th, right? If it's a millionth, like a decimal place and 6 decimal places, it'll be 1e to the -6, right? That's scientific notation. That's what R does with either really big or really small numbers. So you're absolutely right. So I might do my reader a favor and add a little bit of extra, niftiness to this to make it even more legible. So this is GDP per capita US dollars. So it would be nice if I turn this scale into a US dollar scale. Okay. Well, there's a scales package in R that it should install with that code that I sent you. So I can load my scales package. And all I'm going to do here is I'm going to add one more line to my function. Again, I've got my ggplot statement where I define my data and my aesthetic. I've got my geometry line. I've got these 2 lines here that provide plot annotations, again, labels for the axes and the plot title. And I add one more. Here I'm going to make the x-axis, it's a continuous variable. So I'm going to do the x-axis scale. The labels for it are going to be using a $sign. You know what? When I started today, when I was tweaking these notes this morning, I didn't know what this function was. I had never used this function in a plot before. You know what I did, Scott? You know what I did?
Read the instructions for it.
No, what's the thing I always do when I don't know how to do something?
You Googled it.
I Googled it. Thank you very much. Thank you, Sarah. Sarah knows. Yeah, I didn't know how to do something, so I asked Google. Google's really good about finding R functions. If I Googled like how to change the axis in a ggplot to dollars. And I saw this function. And so it's like, okay, I didn't know how to do that until I was writing these notes, and now I do. Okay. So even Sparks learned something. So again, this is a convenience function here, but it's going to add more interpretability to the plot so that the person that's looking at the plot knows what you're doing. Again, if you don't have that, then the plot's worthless. Okay, the plot can be beautiful, but if you don't know what the devil is being shown, then it's worthless. So I run all this code, and sure enough, I get this nice x-axis break now that gives me the scale going from $0 US at the far left to over $100,000 GDP per capita on the far right. Okay, so this gives me an intelligible scale here, so I can see what the actual numbers are that are being plotted. You might be asking yourself, can I put in more breaks? Yeah, you can do that, and that's where if you want to know how to do something, what do? We go and we ask for help, right? So you might go and ask for help on label dollar and look at the help function. And somewhere in here is probably going to tell you how many how to break it into more breaks. Okay. So, look up that's what the help's there for. It's like it's going to tell you what all the arguments to a function are and give you examples on how to use it. But this is a better looking plot. I have a nice title to it. I have the x-axis labeled. I have an appropriate scale so that people know it's being plotted. This is a better looking plot than the first one that was lacking that extra scale label. Okay, so this is a basic histogram in Ggplot. Now you might ask yourself, is there an even easier way to do that? Yeah, there's an easy way to do it that's ugly. You can type hist PRB $GN, and I can get a simple dirty histogram in base R, just like this. Again, you'd have to work a little bit more to make the labels nicer, to make it look as nice as this, and it still wouldn't look as nice as this. But there's more than one way to do everything. Whenever I want to actually make a document, like for a homework or something I'm actually going to turn in, somebody else is going to see, I'm going to put a little bit of extra effort into it to make sure that it looks nice. If I'm just kicking around some new data, I'm probably going to use this simple histogram function to do rough plots of things, just to see what they look like. Okay. So, it's the difference between when you're doing sort of code development, see how things work, versus the final product, which you want to look really nice.
Dr. Sparks.
Yes.
In the line 165, so if I want to add a label to the y-axis, then do I have to just add one more argument here? Just x is equals to GNI, GDP, and comma, and y is equals to something? Oh, okay, y that. Oh.
Yeah. So you could do it like that. That didn't work. Where'd it go?
The plus, yeah.
Yeah. There. Yeah. So it changed it to a capital count, or I could change it to frequency.
Yeah.
So this is one way to do it. So you have a separate function for the X or the Y, or we can do this. This labs function will actually do it all for you in a single place. Y lab equals Q, U, and C. See if that works. Yeah. No, that didn't work. What's the well, I thought you could do that. Oh, okay, yeah. So it'll work like this. So this labs function, you can take a title, give it a title. You can also give it a subtitle. Subtitle equals PRB 2018 data. So I can give it like even more context. Oftentimes what I'll do is I'll give it a caption. So caption would be like data from PRB, RB calculations by Corey Sparks. So and then I have my X and Y label here. Let's see what this looks like. So I've got my primary title, my secondary title, my Y and my X axis labels, and I've got this little annotation down here telling people who made it. Because I mean, if you're going to put the energy into doing something, own it, right? So, you know, anything that you try to put out there that you put some energy into, put your name on it. Otherwise, if people want to know who made it, okay? So this is sort of the, you know, this is getting closer to something that you might use somewhere. There's lots of different, there's so much you can tweak in Ggplot. There are so many different parameters you can set to change the way something looks or to add annotations to things. Like we could go in here and add labels to label the highest value and the lowest value, for instance. Like let's say we wanted to know what this country is, because there's probably only one. Let's say we wanted to label with an arrow pointing to it what the name of it was. You can do that, okay? I'm going to show you a picture of something that I made for this thing that I'm doing with Rogelio. Rogelio, do you care if I show them some of our stuff? It's unpublished.
Oh, no, go ahead.
Okay. So this is a plot that I was doing with Rogelio. This is showing the proportion of, this is the number of employed. So this is using the current population survey to look at the number of employed people in the United States in millions in every month since February of 2020. So right before the pandemic started through the middle of the pandemic, and this is through June. So this is showing just a basic number of people or number of workers, right? Did we decide what that was? The number of workers, I think. So number of workers. We have a line up here that shows the pre-pandemic level of number of workers. We have the secondary line, which is measured as of June 2021. I have this arrow, which shows the difference. And then this number here, which actually shows you the length of the arrow in terms of number of employed people. Everything's labeled nice by month, and I've got my source of my data, and the calculations were done by yours truly, okay? This is, you know, to add these things here is about another 3 lines of code. But it adds a lot more context to the plot itself. And this is what I was talking about. Like when we're done, you know, with the basic stuff, if you want to walk through how I'm doing this, I'm happy to show you all what that looks like towards the end of the class, okay? But this is something that we're going to publish this. This is, I've got all the figures made, Rogelio. I just got to make sure that all the axis titles are right. So this is going to get published as a follow-up piece to one we published last summer. And Aisha is actually, she's one of the co-authors on that. Are you on here? Yes, there she is. Okay. So here's a plot that let me show you a plot that she made. So this is actually a plot, and all this is done Ggplot. This is the proportion of workers who were able to work remotely from home from May until June, from May of last year to June of this year. Again, the lines are shaded by the race ethnicity of the respondent. And this shows you and it's subplotted by gender, male and female. And again, it shows you that that overall fewer males worked from home compared to women early in the pandemic. And it's equilibrated now, but we saw some other figures, some other things too. The most dramatic one was the education one, which shows the ability to work from home based off your education level. This on the far right are those that have college education and more. The far left one are people that have less than high school education. So these are people in frontline jobs that don't have the option to work from home. So they're going to be more exposed to the pandemic, face-to-face work, things like that. They don't have the option to work. And there was this really wild educational trend during the pandemic. Again, this is the ability to sort of take this and split it into 4 subplots is one line of code. Okay, so you're not making 4 plots and then chaining them together. You're telling Ggplot to make a separate plot based off the level of education. Okay, and we can show you. I'll show you how to do that in just a minute. There's a lot you can do to take a simple plot like this and add a lot more depth to it.
Dr. Sparks, I have one question.
Sure.
About in my graphs, when I wrote aesthetic, I put X and Y as well.
Sure.
So in you don't put here Y. So is it because it's like only count? Because in mine it's remote rate.
Yes, exactly. So it depends on the geometry that you're going to be using. Okay, so some geometries want an X and a Y axis defined. Some only want an X, some only want a Y. Okay, so the histogram only needs the X defined.
Okay.
That's because the Y is going to be defined by the frequency. So internally, our Ggplot is going to go through whenever it sees this and count up the number of values that fall within a given bin.
Right.
So that's what the geometry is sort of doing internal. It's creating a histogram. So that's why I'm not giving it a Y here. In a second, I'll give it an X and a Y whenever I have that type of geometry.
Sure. Thank you.
Okay, sure. So nice looking plot, scale, that's that, we saw that. Likewise, we can incorporate another variable to create histograms for different groups. This is what we just talked about. This is called faceting. So I can take a graph, I can facet it by another variable. So if I have a grouping variable and I want to show the plot separately for each group, this is what this is going to do. This facet wrap function will take a plot and split it apart based off which group you fall into. And so here I'm going to make, I'm going to do a little bit more coding. So what I'm going to do here is I'm going to add a new variable to the data set. Okay, so I'm going to add this variable called Africa to the data set. Okay, and what this is going to be is it's going to be an indicator variable indicating whether or not a country is in the continent of Africa or not. Okay, so welcome to your basic first R programming. Okay, we haven't done any programming yet. Okay, we've used some functions to do some things, but we haven't done any sort of logic, any sort of programming logic. This is our first programming logic we're going to do. Okay, it's a basic what's known as an if then else statement. This is fundamental to any programming you'll ever do. It's a decision. The function sees a variable. If the value is this, then do this thing. If the value is this other thing, do something else. This is something that computers are really, really good at, is conditional logic. So to do this, we're going to use this statement here, if else. And what I have to give if else is a test statement. Okay, test statement to evaluate. So so here, let's just do a quick little example over here. Okay, I'm going to go over here. So I'm going to make a vector of numbers from 1 to 10. Okay, we can all see X is it goes between 1 and 10. So now we're going to do if else test equals X greater than 5. We're going to call this high. So this is the yes argument. So if that statement is true, then we're going to call it high. If it's not true, we're going to call it low, and we're going to run it. And what we've done here is we've used that decision function, is X greater than 5, to generate a new variable. This label now low or high. This is what we're doing right here. So I'm asking, does the continent value, does the continent variable equal Africa? And this double equal sign is how R checks for equality. Okay, double equals says, is something equal to this? Let's do this. X equal to 5. What we see here is we see a bunch of falses and one true. The true is for 5, okay, because that's the only one where this equality holds. So that's what we're doing here. So R is going to go through all the continent values, see which ones are equal to Africa. When that's true, it's going to create a new label called Africa. When it's not true, it's going to create a value called not Africa. So I'm going to binary. This is called a binary code of the continent. Okay. The reason I'm doing this is I want to create one plot for non-African countries and one plot for African countries. Okay. So we're going to work through this again. We're going to use a histogram. We're going to change the variable again. We're going to change the variable we're plotting though. And this time I'm going to plot the infant mortality rate. So this is the proportion of the number of children that die less than age 1 divided by the number of children born in a year times 1,000. Okay, this is some fundamental demographic rate that we use to look at population health around the globe. So this is it. My mapping is infant mortality rate. I'm going to use a histogram again. This time I'm going to give the histogram an aesthetic because I want the histogram's color to be different. I want the fill of the bars in the histogram to map onto this new Africa variable that I created. So the African countries bars will be one color, the non-African countries bars will be a different color. Then I'm going to add this third component in here, which is taking these geometries and I'm splitting them into this grouping variable, this African variable. Okay, so facet wrap, and I give it this little formula here, this tilde, and the name of the grouping variable that you want to use. This is going to split. So I'm going to have a histogram for all the different levels of this Africa variable here. Okay, and I only have 2 here. I have Africa and non-Africa. So here's my Ggplot statement. Here's my geometry. This is like an additional geometry function. It's not really a geometry, but I'm taking the plot and I'm modifying it, splitting it into 2. Then I have my annotations. Okay, so this is like a slightly more than 3-step plot, but I'm going to get a more informative plot out of it. And what you get is, oh, that didn't work. No, that's right. That's right. Yeah, sorry. That's right. So what I have here, the plot on the left, this is the histogram of the infant mortality rate for African countries. The one on the right is the histogram for the infant mortality rate for non-African countries. What you can see is overall the distribution for infant mortality in Africa is higher. Okay, so it's more sort of centrally located. The distribution is. While in non-African countries, there's a lot more of these that have very, very low infant mortality rates and a lot fewer that have very high infant mortality rates. So you can compare the distributions then between these two by this grouping variable by faceting the plot. And you know, we've made some of these where let me see which one. View, preview. Like here's one. Here's a plot that from this thing Rahili and Asia are doing where we facet on 2 variables. Okay, so we facet on gender and on education level. Okay, and so you can split these plots into as many different plots as you want to until you know there's diminishing returns here because after a while you've got so many plots that you can't explain what's going on. So you have to sort of pump the brakes and be careful there. But it's possible to explore the data in a lot of different ways by using this facet option. here I just say again, you notice that I use the aesthetic fill equals Africa to tell R to color the histogram bar to color according to the variable Africa. Another way to show this same sort of thing. So here I do a little bit more. Ggplot, I define the aesthetic here. The variable I'm gonna plot this time I'm plotting the total fertility rate. This is the number of children a woman would expect to have if she lives her entire reproductive life on average. The color of, so this is going to be a density plot. So these are going to be, it's like a line version of a histogram. Okay, it's a little bit smoother. It's called a kernel density plot or a density plot. It's another geometry that we haven't seen yet. The color of the lines are going to come from what continent the country is on. The statistic I'm going to be plotting is the density, so it's the proportion. The geometry I'm going to be doing is density. And again, I have my annotations here, my plot name, subtitle, and label for the x-axis. And so here you see, this is the distribution of fertility rates in major world continental regions. You see that Europe has this big high peak at less than 2, about 1.5. So the European fertility rates are some of the lowest in the world. There are a few countries in Southeast Asia, especially or East Asia, especially Korea, that have lower than European rates. And then you see the other end of the spectrum is on the distribution for African countries has a lot more variation to it, and on average would be much higher on average. So it's the mean of the African TFR would probably be about 4, while the mean of the European TFR would be about, I don't know, 1.6 or so. So this is, you have the ability in Ggplot to make all the different geometries, different colors. You can make them split into facets. There's lots of different things you can do here. And again, my job for tonight isn't necessarily to show you everything you can do, just to show you a few things you can do and set you up with a general framework of how you put things together. Okay. Another type of plot that you see a lot to do distributions of variables are stem and leaf plots, or also called box and whisker plots. This is useful to show the distribution of a continuous variable across values of a categorical variable. So here I'm going to take the x value is going to be constant and y is going to be the TFR. So the value on the y-axis is the fertility rate, and I'm going to show the fertility rate distribution for each continent. I'm going to do a box plot geometry, and then I'm going to do a simple annotation, again, showing what the title of the plot is and a subtitle that is coming from 2018. And so here you see then, this is another way to do this. They're showing the exact same information. This time that the box and whisker plot is like you're looking down on the distribution versus looking at it from the side. So again, so here's the distribution of the TFR in Africa. You can see what this is the median or the 50th percentile of the variable. It's a little over 4. Here's the European one. Its median is about 1.6. And you can see the whole distribution. This is just another way to see the entire distribution of a variable, but again, it's mapped against a categorical variable on the x-axis. Some people don't like things like this. So what they'll do is they'll flip the coordinates. This is another nifty trick that a lot of times you can do in graphics, where instead of looking at the categorical variable across the x-axis, you flip it and you end up with a plot that looks more like this. In this case, the fertility rate now is mapped on the x-axis, and the y-axis is showing the grouping variable. Okay. Again, these are good visualizations to show distributions of a continuous variable across values of a categorical variable. If you've ever had statistics before, this would be a good plot to illustrate with the analysis of variance, for example. Okay. So I'm gonna take this. I'm gonna add a little bit more context to it, and I'm going to add a little bit more color to it. So what I'm going to do here is I'm going to combine the continent variable with the region variable. So I'm going to show sort of within continent variation in the fertility rate mapped onto the region. And those are two different variables in the data. If you go back over to our data here, you'll see there's the continent variable. And then within that, there are subregions of the continent. For most continents, I think North America only. North America might have two. South America only has one. So it's like a nesting. It's like a hierarchy. You have countries nested within regions, regions nested within continents. Okay. So in this case, we have like a 3-level hierarchy. So what I'm going to do is I'm going to use this paste function here. And what paste does is it concatenates two pieces of text together. So if I have one thing here that tells me the name of the continent, and one thing here that tells me the region name, if I paste them together, it's going to stick them together. Okay. So it glues them together, pastes them together. Okay. So now it's going to be the combination of continent and region together. This is a concatenation. So you may have seen that term before. There's a function in Excel to do concatenation of strings. So what we're going to do here is I'm getting a little ahead of myself because I'm getting into some dplyr stuff here, which we're going to do immediately after after the break. Dplyr it allows you to take variables that exist, and like we used our conditional logic before to make a new variable, I can make a new variable as I go. So what I'm going to do this is called a mutate step. And I'll go more into this after the break in dplyr. But I'm going to mutate a new variable. And I'm going to make this variable called new name. What's going to make this new variable is I'm going to paste the continent variable and the region variable together. And I'm going to separate them with a dash. So it's going to be Africa dash Algeria. Or Africa dash North Africa, Africa dash Sub-Saharan Africa, something like that, okay? So it's going to take these two strings and combine them. Then I'm going to use this new variable directly as my x-axis title for my new plot. Okay, so I'm going to make the variable on the fly and then use it immediately. I'm still plotting the fertility rate by continent, so I'm going to have the color vary by continent, but I'm going to have this new region variable be in there too. I'm going to do box plots. I'm going to flip the coordinates, and I'm going to do labels. And what you get out is something like this, where now I have it, because a lot of times you may be more interested in the smaller level variation, especially when you're dealing with aggregate data, than looking at something really big like a state or a nation or a continent. This allows you to see sort of where the variation is lying within this larger area, okay? So for instance, you see that there is a lot of variation, say within the continent of Asia, within the continent of Africa here, where Southern African and Northern African countries actually have much lower fertility rates than Middle Eastern and Western African countries do. So it's not that the entire continent of Africa has high fertility. There's variation within that, okay? By doing this, you can see where that variation is within the larger continents. The colors correspond to what continent a given country is on, but then the labels here are the subregion within the continent. So this is just, a way to tease apart the variation in a variable in a slightly more informative way. XY scatter plots. This is another geometry. This uses a point geometry to map an X and a Y variable together as dots. So here's a simple mapping of this. So again, I have my Ggplot, my aesthetic. The x-axis is going to be the fertility rate. The y-axis is the infant mortality rate. For those of you that are new to demography, there's a very good relationship here. Countries that have higher fertility rates typically have higher infant mortality rates. There's a lot of theories in terms of why that happens. In the past, it was always you had to have more children to replace the ones that died, especially if you're in an agricultural setting and you need the household labor. That's sort of stuff I did my dissertation on. So the x-axis is going to be one continuous variable. The y-axis is going to be another continuous variable, and I'm going to plot them against each other using a point geometry. I add my plot annotations here to label everything, and you end up with this. Okay. So the dots are individual countries. The x-axis is the fertility rate. The y-axis is the mortality rate. And you see this nice positive relationship between the two variables. Okay, that's what we do scatter plots for, is to look for direction of relationships oftentimes between two variables. This is a pretty nice positive, maybe linear relationship. We can take this set of data here and lay a line over it to show us what the relationship looks like. To do that, we can add a smoother. So this is our first geometry, which puts the points on the plot. We can add a second geometry to this that shows us a linear regression line. So the linear function that maps onto those data to show you the overall trend. Here I'm going to do that. I'm going to add a linear line. I'm going to add a straight line. It's going to be black. I'm going to add another line to it, which is blue, which is the lowest regression line. This is a nonlinear function. Because a lot of times in statistics, we assume things are linear, but they're often not. And you'll get more about this the next 2 semesters of your life, so I'm not going to go through a lot of this. But what I'm showing is that you can layer multiple geometries on top of each other. Okay, so you can do a lot of things in a plot. So here I'm showing the original data in the black dots, the linear function that maps onto the data, and then this blue line shows you the curvilinear relationship between the two variables. And they're almost the same, so there's not much difference here. But I'm just showing you this. If you wanted to take these data and summarize them with a single function, we just did it to show the positive or negative relationship between variables. We can take this furthermore, and we can take the dots, and we can have the aesthetic map the color of the dots onto the continent in which they lie. And what this is also going to do is it's going to take the smooth geometries of these lines, and it's going to color them by the continent too. So now we have the dots colored by the continent in which they lie on, and the direction of the color of the line that shows the relationship between the variables is also mapped onto the continent as well. And the cool thing that you can see here is that in most regions of the world, there is this strong positive relationship between fertility and mortality, except in Europe. In Europe, it's almost a flat relationship where there is no a slight negative relationship. So higher fertility leads to lower infant mortality. This is sort of an ambiguous case here, which bucks the overall worldwide trend in the relationship between fertility and mortality. Okay, in statistics, this is called Simpson's paradox, where if you take a look at the whole picture, you see one relationship. But if you break the picture into a series of groups, you may or may not see a whole different set of relationships. Okay, so this allows you to kind of visualize that. I can take this and facet it. Again, everything's the same except I add this facet wrap function in here to take, and now I'll split the data into continents. So each continent now will have its own scatter plot, and you can look at the relationships. Maybe easier when things aren't all together. We did that. Okay. That's a lot. I know that's a lot. We're going to take a break for 10 minutes. Are there questions in the chat that we need to talk about before we take a break, though?
I think we resolved everything.
Okay.
Although I'm not sure, Lily, did you get yours resolved?
Yeah, I think it had to do with the spelling of dplyr. There's 2 different packages.
There's plyr and there's dplyr.
Right.
I'm using
Challenging.
dplyr. Yeah, they're both written by the same person. So Wickham wrote them both, and dplyr sort of supersedes plyr. Although there's still a few functions in plyr that I use sometimes. I'm hoping they don't get rid of them because they're brilliant and they do really cool things that nothing else does. Okay.
There is a question about pipelines here.
Yeah, so the pipelines we're going to deal with right after the break. That's a dplyr thing too. We're going to spend the next hour talking about pipes. Basically, it's a simple way to connect statements together to each other without having to completely redefine the name of the data set, for example. We're going to spend a lot of time with that in just a few minutes. Okay, so it's 7:05 on my clock. So why don't we take 10 minutes, come back at 7:15, and we'll pick up again talking about dplyr and more data summaries. Okay, thank you. We get started. Okay, as always, put anything in the chat if you have questions about. We are going to get around some of the questions, especially around the little percent greater than thing. We call that a pipe in R. So we'll talk about pipes. We use a lot of pipes next. The pipe is a relatively new thing in R. When I first started this, so this whole sort of tidyverse thing only has existed for like the past 5, 6, 7 years. Before that, you worked in something called base R, which you can still do all the same stuff in, but it wasn't nearly as legible or easily explainable. It was much more complicated to do something that's simpler now in dplyr and Ggplot. I used to make these plots in base R that were just a lot of lines of code, and it was just really, really ugly. And I'd be so scared to death if I had to go back and try to run them again now, because I think something would break. So we're going to get into dplyr now. And dplyr is one of the fundamental parts of the tidyverse that allows you to take data, manipulate it, summarize it, and then link it to other things, all in a single workflow. And this creates a really legible, easily followed sort of trail of what the data are doing. So dplyr has a lot of different functions that work together, and they designed it so that the code that it creates are succinct, readable, and highly functional. Before I started using dplyr, I would always say, I would compare like R to SAS, because I learned SAS first. And using R, it would take something like 10 lines to do something, but in SAS, it would take like 50 to do something. So it was much more succinct, compact code that would do things, the same thing in less real estate in terms of amount of stuff you had to write. And then I learned dplyr, and then it was even more succinct. It was even easier to do complicated things, much easier than it was ever before, and anything I'd ever seen before. So the package, dplyr package, consists of a set of core, what they call verbs. So these are action words that do things, right? These are used to clean, reshape, and summarize data. There's lots of different verbs for different things. You chain these verbs together by these pipes. So this allows you to take one action item and connect it immediately to the next action item. It's like what Scott said in the chat to answer Selena's question, is you take one command and you immediately take the result of that command and put it into the next command. So there's nothing's lost. You don't have to repeatedly call the data multiple times, and it presents a very, very succinct way to take a data set at the top and perform a repeated set of actions on it. And that's what these pipes are, those percentages with the greater than sign. That's what they call a pipe. The idea is that I can chain several of these verbs together, only having to name the data being used a single time, which makes for efficient code. And once you start seeing these things a few times, you'll start to realize, you can chain lots. This can be very simple. This can be very complicated. You can chain lots of things together, or you can do just a few things to summarize things and make new variables. Lots of functionality built in. The pipes also allow for variables within a data frame to be accessed by any function without having to use the $sign notation that we talked about yesterday. So what we're going to do is a short sort of commonplace thing that you may be asked to do. This would be like a classic homework I would have assigned in Stats 1. I'd give you a bunch of variables and ask you to calculate summary statistics for different groups in the data for a bunch of different variables all at the same time. So, in the past, you might have, done the mean of one variable for each group separately. And then after doing that for 10 different things, you'd have your analysis done, but there's more succinct ways to do that. We're going to be using the PRB data again, and we're going to be doing a series of tasks. The first thing I'm going to do is I'm going to use one of the most commonly used dplyr verbs, the mutate verb. Mutate takes one variable and creates a new variable from it. There's the core mutate function, and there are other mutate functions that can take a bunch of variables and do a transformation of all those. We're going to do one variable at a time though tonight. So the first thing we're going to do is we're going to take one variable, mutate it to make a new variable from it. Then we're going to group the data into groups. This is similar to SAS's by processing. So SAS was always famous for its ability to take a procedure and repeatedly apply it to different groups in a data set really, really easily. You sort the data and then you run the process, and there's this by statement that will repeat the process on the same variables in every group separately. And you have this nice grouped summary analysis at the back end of it. This is the equivalent of that in R and in dplyr. It's called the group by function. Okay, so you can calculate summaries very efficiently across multiple groups. Then we'll do some statistical summaries of some variables in the data using the summarize function. Summarize function will allow you to calculate basically any type of summary function that you see in R. It can count stuff for you. It can take the mean of something, the variance of something. It can take an arbitrary function of variables and do that. It's really, however you want to take a bunch of data, group it, and then summarize it. There's a lot of functionality built in here. So this is a very, very, very typical workflow in dplyr. I realized when I started looking at my code right before I started talking, like I'm doing a lot of stuff in this first example. So I'm gonna move right over to my R Studio and do a slightly simpler example first. I'll send out this updated version of the notes for this simpler example first after class. But I just want you to follow me for just a second, because the example I have in the notes does a bunch of stuff, but I wanted to start with a simpler example that only does one thing. So what we're going to do here is we load our library so we get access to the functions. And the first thing we do is we identify our data set. So this is our data set that we have loaded into R. And the first thing we're going to do is we're going to pipe it. So this is telling R, take the data and put it into the next function. And what this is going to do is this next function, mutate, is going to then have access to all the information in this data set without us having to name it. You could go and do something like data equals PRB here, but you don't have to, because so you save having to do this with every verb when you name the data at the top and pipe it in. So what we're going to do here is we're going to mutate and make a new variable. I'm going to make a variable called high TFR. This is going to indicate whether or not a country has a high fertility rate or not. In this case, I'm using my if then else, if else statement like I talked about before. So I'm going to do some logic. So my test is I'm going to ask R to identify which countries have a TFR greater than 3. So this is a woman having more than 3 children we would consider to be a high fertility country. If women on average in the country have less than 3 children, it would be called a low fertility country. It's an arbitrary distinction, but I hope you see my logic. So if it's higher than 3, then we're going to label it as a high country. If it's less than 3 or equal to 3, then we're going to call it a low country. Okay. So this is making this new variable from a variable that already exists using some logic. And a lot of times whenever I'm doing stuff in R, I'm going to show you a really ugly thing I probably shouldn't show you. So whenever I do this sort of in practice, what I'll do is I'll have a bunch of these mutate steps all chained together. So here's a single, I take a data set, I pipe it into the mutate function, and within the mutate function, I make 1, 2, 3, 4, 5, 6, 7 variables. So there's no limit to the number of transformations of variables you can do in a mutate step. It's completely, you can do as many as you want to. And oftentimes when you're working with raw survey data, certainly you'll get a lot of experience doing that in stats too. When you're working with your own survey data, you have to do a lot of recoding of variables. So it involves a lot of if then else statements. So if a variable is less than 0, then coded is missing. If it's not, then there's a lot of this stuff that goes on when you're actually working with survey data. And y'all all do a lot of that real soon. So this is working with working with survey data set where I have to recode a lot of variables. Okay. So this is doing but here I'm just doing a single one, right? A single mutation, making it one new variable, indicating whether a country is a high or low fertility. Once I'm done with that, I'm going to group by this new variable that I just made. So this is going to take the data and split it into 2 groups, high fertility group and low fertility group. That's what this is telling R to do right here. So once I split it, then I'm going to feed that into another function, the summarize function. And this is like a classic dplyr workflow. Take some raw data, change the data, group the data, summarize the data. That's like a really classic workflow that you'll see repeatedly over and over and over again in dplyr. And it's something that I've really asked any of these students that are on the call that have had me before. This is something that you'll see me do a lot, and it works in a lot of different circumstances. So we're going to summarize now. And whenever you summarize, you're going to summarize a variable. You can summarize more than one variable. You can do lots of different summaries at the same time. You can do a lot here. That's why I wanted to start with like a slightly simpler example. I'm just going to summarize one variable and show you what that looks like. So I'm going to summarize a variable in this data set, and I'm going to call the summary output of it mean E0. E0 is notation in demography for life expectancy. Life expectancy is the average years of life a cohort is expected to live if they experience a constant set of mortality rates. You'll hear about that from Dr. Science and Dr. Potter before you know it. So this is one of the classic metrics in demography. You've probably heard this recently. Life expectancy has gone down due to us being addicted to opioids and COVID recently in the US. So this is a life expectancy measured at the national level in all these countries. So what I'm going to do is I'm going to make this new variable, mean E0. I can call it cat, I can call it dog. It doesn't matter what you call it. Okay. I prefer to call it something that makes sense. So that's why I'm calling it mean E0. What's going to be summarized, what's my summary function, is the mean function. So I'm going to take the average of E0 male. This is male life expectancy in the country. The PRB calculates male and female life expectancy separately. So this is going to be the average years of life lived by men in countries, classified by whether or not the country is high or low fertility. As we saw this night, there are missing values in this. So I tell R to remove any missing values before calculating the mean. So we're gonna, and this works just like dplyr. All these things are piped together. I can put my cursor anywhere in the middle of it, hit Control Enter, and I get my summary. So this is what's produced. So I took these 208 rows of PRB, made a new variable, grouped by that variable, and summarized another variable in the data set by those two groups. And what I get out here is a statistical summary of life expectancy in these two types of places. So in high fertility countries, life expectancy is about 62.7 years, which is pretty low. In low fertility countries, life expectancy is 73.5 years. So you see a gap in life expectancy of over 11 years, depending on how high or low the fertility of the country is. Okay, so this is a classic sort of thing where you'd be asked in your stats class to do a statistical summary, calculate the mean and standard deviation of this variable across this group in the data. Classic type of analysis that you will do all the time. Whenever you're doing a research paper, you always start out with a descriptive analysis of your data. This is a way to do that. Okay, there's 10 other different ways to do it that are doing the same sort of thing, but this is a good initial way to learn this workflow. So this is why this is doing a single thing, one variable across the groups. The notes I gave you jump right in and do a lot of stuff. Okay, so I'm going to do multiple summaries at once. Okay, so the first thing I'm going to do is I'm going to count up how many countries are in high and low fertility areas. Okay, because what if there's only one? What if there's only one country that's a high fertility country? Well, then the statistical summary of it wouldn't be very meaningful. Typically, we like to have a lot of data to perform our statistical summaries on because we have more accuracy and more power to make statements. So I want to know how many countries are in each one of these groups. So I'm going to make the first summary variable I'm going to make is called n. And it's actually going to be coming from a function called in parentheses. So there's a function called nr, in dplyr. If I do question mark in, I'll see, sure enough, there's context dependent expressions, all these different weird things that R will do. N gives the current group size. Okay, so that tells you how many observations are in a high fertility group and a low fertility group. Then I'm going to summarize across, that's what this verb is, across. We'll take a bunch of variables and apply a summary function for all of them. So here I'm going to take the columns of the data set, male life expectancy, female life expectancy, GDP per capita, and the infant mortality rate. And I'm going to take the mean of all of those. So I'm going to take multiple variables, take their mean across the two groups, high and low fertility. I'm also going to get the number of observations in each group. So when I do that, a lot of times what you'll see after you do a group statement like this, you'll see people do this ungrouped statement so that the output of it is, it's called an ungrouped data frame. A lot of times in my work, I will not do this, but a lot of like dplyr purists tell you to do it. So I'm showing you all to do that. So what you get out then is, the one I showed you over here was a simple one. I had a single new variable calculated, average life expectancy in high and low fertility countries. When I do this, I get the sample size in each high and low fertility country. So there's 68 high fertility, 142 low fertility. And then I have the average life expectancy for men and women, average GDP, and the average infant mortality rate in those two contexts. Okay, so this is a way to summarize multiple variables simultaneously across this grouping variable. This is a very, very standard sort of thing to do in dplyr, where you summarize data. Here, I'm walking you through in the text here exactly what we just did. The PRB pipeline says take the PRB data and feed it into the next verb using the pipe. The next line, mutate high TFR, tells R to create a new variable called high TFR. The values of the variable will be created based on conditional logic. If the value of the TFR is over 3, the value will be high. If the value of the TFR is less than or equal to 3, the value of the variable will be low. The next line, group by, tells R to form a grouped data frame. So it segments the data into discrete groups based off the variable that we specify and performs operations on each one of these groups separately. This is the same thing as data stratification, okay, which you'll hear about as you get in more and more into analysis of real data. Oftentimes you'll stratify an analysis to see how an analysis works separately across multiple groups. It's a classic sort of way that demographers, there's this classic sort of demographic joke. It's like, why are there no old demographers? The answer is because they're all broken down by age and sex. This is that's sort of the demographer's joke about constantly stratifying every analysis that we do by age or gender or race, ethnicity or education. That's sort of one of the things that demographers add to social science, is we don't just assume the thing works the same way for all people. We like to break it down and see how it works differently. The last line, the summarize function, tells R to first count the number of cases in each group using the in function, then summarizes multiple variables across the two levels of the high TFR function. Then finally, we ungroup the data frame to remove the grouping, and this is customary whenever the group by function is used. Then we see our estimates, and we can then, this could form the basis of a lot of discussion. You could write paragraphs about, this is the comparison, this is how big the difference is between these two groups. And that's how a lot of good descriptive demographic work is done, is you take data, you summarize it for multiple groups, and you talk about the differences among the groups. Other dplyr functions, what other things are there that exist? A common one that is used a lot of the time is called the filter function. The filter function will take a data set and subset it to only contain certain cases, okay? So this is, I think this verb is actually taken over this process, and everything that I say, it's always filter, 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 filter all the time. So here I take an example and I only select data that come from Asian countries. So I take the data, I mutate it, then I filter it. So now I've got high and low fertility countries, but I'm going to filter only countries that are in the continent of Asia. So I'm going to basically delete all the other countries, all the other continents from the analysis, just use Asian countries for the analysis. Then I further group by the fertility variable, and I do my summary again. So here now, this would be the statistical summary just for Asian countries. So high and low fertility Asian countries. So low fertility Asian countries have about a 4-year difference in life expectancy for men and about a 5-year difference in life expectancy for women. GDP per capita is about $21,000 higher in low fertility countries in Asia. And the infant mortality rate is about a third of what it is in high fertility countries. So, this allows you to sort of further subset the data so that you're just talking about a specific group in the data. We can do it a little bit fancier. So let's do do continent in. So now I'm not going to just say one value. I'm going to give it multiple values. So let's say I want Asian and African countries. So I'm going to do, I'm going to give R a list of values. This is the C operator. It's how R forms a vector of values. I'm going to do Asia and F. So now, if the country is either in Asia or in Africa, then it will go into the analysis and do that. I could do something else here too. I could add multiple group by variables here. So now I'm going to group not only by high and low fertility, but also by continent. So this is like a two-way, you know, if you've had some stats, this is like a two-way ANOVA. So I've got two different grouping variables that I'm looking at in my analysis here. So now I can compare high and low fertility countries, high and low fertility settings in these two continents across these variables that I'm summarizing here. And again, this is good, solid, descriptive demography in action. Okay, this forms the basis of a lot of descriptive analysis that demographers do. And you know, we don't all the time fit complicated models that take 3 days to run. A lot of the best demography that's done out there are people taking novel data sets and drilling into them like this to ask questions that are serious and of interest to you. And that's sort of the thing that I think that our program does, is it lets you look at data how you want to look at it and ask the questions that are interesting to you. Okay, this is a classic way to do that, and it's not rocket science. It's just averages, but averages can be very powerful if used in the right context. More dplyr summary functions. I like this one a lot. This one's called distinct. If I take PRB, if I just take the data and put it into the distinct function and give a variable, it'll list all of the unique values for that variable. So here's just what are the distinct values for region, and it just lists all the different values of that variable. Okay. So if I have a big data set and I want to see what all the unique values are for a variable, this is one way to do it. If I want to count the number of distinct variable, the number of distinct items, then in distinct will do this. So in distinct of a variable. Here I'm not using it in a pipe. I'm just using it as a function on a single variable. I don't have to put, you don't, that's the cool thing about dplyr stuff, is you don't have to do this piping stuff if you don't want to. It makes your life a lot easier if you're doing several functions at once. Absolutely makes your life easier by chaining them together. You don't have to. Okay. If you want to use a mutate step in isolation, that's great. It does a great job. In this case, it just counts up the number of distinct continents. And in the data, there are 6 because there's no countries in Antarctica. Okay. Counting is a demographer's best friend. That's what demographers basically do, is we know how to count stuff so that we divide by the right denominator. Okay, that's what a lot of complicated math and demography is. So this tally function is, you know, it's like my kids were in kindergarten, they were learning how to count things. They're like 1, 2, 3, 4, 5, 1, 2, 3, 4. That's tallying, right? There's a function called tally that will, so here we go. We'll feed the data in, we'll group by continent, and then we'll tally. So this is going to count up the number of countries, the number of observations in each continent. So this is basically making a histogram. Okay. So there were 57 countries in Africa, 51 in Asia, 45 in Europe, so on and so forth. The cool thing is that, okay, I can do these summaries and I can have it print out here on the page. But what if I took these summaries and then I piped them directly into a plot? And this is really where the tidyverse starts to become really useful, is I can make a single workflow where I take a data set, change variables in it, group it, summarize it, and then plot it. This is sort of my life right now. Like the stuff I've been doing with Rogelio the past, month or so. I don't know, Rogelio, how long have we been doing this? A year. This has like been my life every single day. Is I take a data set, change it, group it, summarize it, plot it. And that is a really powerful way to take, you know, 1 million lines of raw data and make it really intelligible and translatable to an audience. So we're going to do that. Real simple. And then I can show you a real complicated one later on after sort of I get through with this core material if you want to see it. So here we're going to basically take this workflow where I count up the number of observations in each continent and then plot it. So I'm going to make sort of I'm going to hand roll a histogram. Okay. So I take the data, I group by continent. I'm going to count how many observations are in each continent. I'm going to feed that directly into Ggplot. So I'm going to take this summary, I'm going to put it right into Ggplot, and then I'm going to have my Ggplot syntax take over and go from there. So I take my tally output, which is the count of number of observations in each continent. I'm going to feed it into Ggplot. Here, you notice I don't have to tell Ggplot the data because the data is coming immediately from his. Okay, that's the value of this pipe operator, right? Is it takes the output of one function and puts it immediately into the adjacent function. So I'm going to make a plot out of this. The geometry is going to be a bar, so it's going to be a simple bar chart. The aesthetic here, if you want to see what this looks like, this can be valuable. Watch this. So here's my data. So the output of this tally function is a new variable called n, which is just the number of observations, right? So I can use this variable in my plot statement. That's what I'm going to do right here. So the y value, the y-axis is going to be scaled by n, the number of observations. The x-axis is going to come from which continent it is. And so that's what this is doing here, right? The label for each axis bar is going to come from continent, and the size of the bar is going to come from n. The color is also going to vary by continents because I'm going to have each bar, instead of having all these bars be gray, I'm going to have the color vary by the continent as well. And the statistic that I'm going to, since this is the exact value that I want to map, that I want to plot, you say stat equals identity. So it doesn't try to do some other statistical transformation of it. I want to take this summary information and plot just that. Don't do anything else to it. And so sure enough, I get this nice, you know, it's very colorful. It's nice. It's a really simple like bar chart histogram of the number of observations in each continent, which isn't groundbreaking, but this is a general example, right? This is a simple example that, you know, the idea is that what I'm trying to give you all is a recipe card, right? These are the steps. And what y'all need to do is take your ingredients and put them in the recipe, and then you end up with the final thing that you want to eat, right? This is the exact analogy because I like food. I'm a cook. I like to cook a lot. And that's the analogy that I use all the time with our stuff is I want to show you a general framework in which to work in. Then you put in the stuff that you want to look at and make it yours. Okay, we're going to pump the brakes right there. Again, I'm happy to spend some more time looking at some real examples sort of in a couple of minutes, but there's a couple more topics that I have on the agenda that I want to talk about just because I think they're important. The next one I want to talk about are R file types. So this is totally shifting, gears. R has a lot of different file types that it works with. The basic type of file that we worked with last night was a simple code file, a .r file. This is where you can make a variable, you know, 100, just like we were doing last night. Just x, mean x, things like this. We can run the whole file. It'll do all the job in the R file. It'll put the output wherever you want it. This is like the basic R file that you write code with. There's a slightly fancier version of the R code file called RMD files. These are called R markdown functions, R markdown files. And this is actually what I write all of my lectures in. This is an R markdown file that produces, so the basic R script will do any analysis that you want it to, make any output that you want it to, and it's wonderful, right? But once you get to the point where you know things work and you want to actually do something with this, you want to make like a formatted document. You have something to say first, then you do something, then you have something else to say about that. So, you know, I've gotten to where in my life where I like to do is I like to write the entire paper in R. I'm writing a book. I'm writing a book on R in applied demography. And I'm writing the entire book in R Markdown. I can include all my plots, all my code, all my citations, all my bibliographies, all of my images in a single document that compiles into like a 200-page book. Okay. So this R Markdown files allow you to do a lot more. It produces a formatted document. The notes that you're looking at on your computer right now came from this R file. I can do lots of stuff with it. I can make tables. It produces formatted documents. Okay. These formatted documents can include tables, figures, statistical output. You know, this entire lesson is written in R Markdown. It can produce nice looking LaTeX equations. So, you know, when you get into my stats class, for sure, you'll see a lot of equations thrown at you about what different models look like. Well, you can write the entire model. Where is that? You can do all the math. You can write all the math. Like this is a LaTeX equation right here, which is like a text version of a mathematical equation. It all goes in the document and it prints out really nicely. It can print out in PDF, in Word files. It can print out in HTML, like the thing I sent you guys is a web page. I can make a nice table, so I can make a nice, pretty formatted table, 15 different ways in these R Markdown files. Again, I can make the entire analysis and write-up in one of these things. So this allows you to do a lot of things in a single document. And if I want to go change something, guess what I got to do? All I got to do is I go in here and I change something in the analysis. I recompile the document, and guess what? The whole thing is repeated. You can't do that clicking buttons, friends. This is the value of writing code. Not only do I get to write code and do my analysis, I get to write the entire analysis in a single document. And all I got to do, if let's say I wanted, you know, there's a lot of people that do very formulaic types of analyses. Like, you know, you get into this, you know, in academia, a lot of people get into this stride where they do very similar analyses. They change a few things in the front end of the paper. They change the outcome variable. They change the predictor. But a lot of the paper is fundamentally very, very the same. This like puts that sort of mill of, you know, writing and doing analysis at your fingertips, because you change it, you hit run again, and the entire thing is recompiled with the changes included. Really powerful way to do repeatable research. The only way to fly. Putting these things together is something that in the past couple of years, I have really started using these things a lot. R projects. So this is a way to take a bunch of R code files and data files and images and tables and things like that and put them in a single place. This has coincided a lot with me using GitHub to store all of my materials. So like this, you might see on my RStudio, this thing up here in the top corner. This is my project name. So I've got a project for all these little courses I teach on R. And so I have all of the materials for them all together. So I've got my boot camp thing here. I've got one that I did on my summer workshops from last summer here. I've got some ones that I've taught at A&M before. They're in here. They're all like the code files that make the whole presentation, okay? And this helps you organize your life around each project. And like I've started, so like the stuff I'm doing with Aisha and Rogelio, I've got an unemployment project. So I switch to that project and it picks up immediately where I left off, writing my code. It syncs to wherever all the files for this project are located. So I can immediately be working in its location. So this is a really cool way. You know, I would do this with your classes, your stats classes. Have an R project for each stats class so that you have all your code files, all your data files in a single location so it's organized. You know, not being organized in grad school is a quick ride right out the window. I mean, it's being organized is really key at this level. And so if all your stuff's in one place, it's one less thing to have to sweat. This also contributes really easy to using things like GitHub and version control, so it'll track the changes in the files for you. And it's easy to share things with other people, so on and so forth. I've gotten to where like Sarah has been working with me pretty closely on a paper over the past 6 months or so. We share a GitHub repository on this paper that we're writing. I can go and make changes. She can go and make changes. We can merge them together. And that's a cool way to collaborate with people, right? Because you're not just constantly emailing files back and forth all the time. You have a single place where you go, everything's there, and you can work on it together. Data files. R has a few different data files that exist. It has two native data formats, RDS and RData. There's a big difference between them. An RDS file allows you to store a single R object to an external file. So let's say I wanted, and Scott taught me this. I did not know this before I started working with Scott on a project a few years ago. And he kept saving all these data files as these RDS. And I was like, I've seen this before. What is it? He's like, yeah, this is how you save a single data frame to an external file. So let's say I had my, where is it? Let's say I had my PRB data here. PRB data, where are you? Here's my, no, not that one. Here's my PRB data. Okay, so I read my PRB data in, it's there. Let's say I wanted to save it. I can do save RDS. I can give it the name of the data frame, file equals, and give it a location where I want to save it. My PRB.RDS. And it's going to save it to wherever your working directory is. And so sure enough, I hope that there is a file right here now called myprb.rds. So I wrote it to an external file. It's a single data frame. Let's make a copy of it. PRB2 is PRB or oops, PRB. So now I have two things in my environment here, PRB and PRB2. I can use save to save both of them together. So this saves an R data file. So we do list equals PRB, PRB2, file equals my PRB2.RData. Hope this works. Nope. There we go. So this object now, my PRB2, it doesn't just have one file in it. Where'd it go? My PRB2. Yeah. So if let's close this down. So we're going to close the project. So we're like going to start a new R. And what we're going to do is we're going to go to files and we're going to go find that. And what you're going to see is it's going to put both of those data frames back into our R session. Courses, boot camp, yeah. So I load it, yes, and there they are again. So what the R data files do is it'll allow you to store multiple objects in a single data file. And so a lot of times I do I'm like kind of an egghead, right? I'll run these models to take like a day to run or more than a day. And when it finishes, I want to save that stuff because, you know, the computer's been sweating for 2 days running this model. So whenever it finishes, I have it write all of the output and like all the stuff that I derive from it into an R data file. So I don't have to spend 2 days running all that garbage again. So, you know, that's just, I save my work, right? Okay. So those are the fundamental. Yes.
Yeah. So I was working in the other GRA with the CHAP study. So they're going to do 3 different paper, but using the same data frame. But I was trying to This one really helped me right now, because I will use those 3 or 4 data frames in a single data, just the way you show us today. I will
Sure.
use that one. That's really helpful.
Okay, good. That's great. Yeah. That's what the R data files are for. They'll save a lot of different things. Yeah. Good. To read them, there's a read RDS file that'll read an RDS file. There's a load function that'll load an R data file. So on and so forth. We talked about this reading SAS files yesterday. Useful packages. Again, there's thousands and thousands and thousands of R packages, right? In a daily, in any given day, because I use R every single day. I mean, I do everything in it. In any given day, I'll probably use like 5 to 10. That's a very complicated analysis or something if I'm using 10 packages. A lot of the stuff that I do will use dplyr, Ggplot, a package that does survey data stuff, and that'll form the basis of a lot of work that I do. But there are some that are really useful. What R does is it'll take a lot of these packages and group them into what are called task views. So if you're interested in getting packages that are sort of thematically related, this is a really good way to do that. So the list of task views you can link from the notes here. Maybe it doesn't do it. I'll have to fix that. Yeah, I'll have to fix that. So these are thematically linked groups of functions. Here's one on social sciences that I like a lot. And it probably has, oh geez, how many functions? All these different functions in it. So I can go and I can install a task view, and R will install all these functions for you, okay? And so that's a really efficient way. Instead of installing them one at a time, you can say install the task view social sciences, and you'll get all those packages installed automatically. Because I mean, right now on my computer, I probably have 300 R packages installed, but I'm not going to go by hand and do all that. That's, I have a big mantra. It's called work smarter, not harder. This is working smarter, not harder. Do one thing that does a lot of things for you instead of doing a bunch of separate things. Come on, nobody's got time for that. There's an econometrics one that's pretty good. There's a spatial one. There's a Bayesian one that I use a lot. And you can install these using this CTV function. So if you want to, you can install that using the install packages thing, load it, and this install views function will install any one of these task views for you. It'll run the computer for a minute, like it's library CTV install.views. Whoops, I didn't spell right. Install.views social sciences, and it'll run for a couple of minutes. It'll download dozens of packages for you, and then you have them, right? Instead of having to go do it piecemeal. That's a really efficient way to do things. Occasionally, the authors of packages will make updates to them. And so there's an update packages function that will go through and check to see what the current version of the package you have installed on your computer is versus the current one that's up in R land. And so that'll let you update the packages automatically with one single command. I probably do that like once every couple of months. Certainly every time I install a new version of R, I'll do a new install of all the packages for that version, things like that. Okay. And last but not least, one of my very, very favorite packages in all of Ardom is called Tidy Census. This is a package written by a wonderful guy, is a geographer at Texas Christian University in Fort Worth, a guy named Kyle Walker. Wonderful guy. This allows you to connect to the Census Bureau's all their data directly. So you don't have to go download files and search for things. You can download the entire American Community Survey and put it in a map in 30 seconds. It's remarkable the functionality he's built into this. You can get the PUMS files, you can get the ACS microdata, you can get the ACS summary files, Census 2000, Census 2010, all this great data right there using the Census Bureau's API. We spend a lot of time in the GIS class working with this. We work with this like every day. It's a wonderful way to get a lot of information, put it in a map really visually with one line of code. It's remarkable the functionality he's built into this. Okay, so that is sort of that's the end of what I have right now. Do you want to see some gory looking R code? That's the stuff that Aisha and me and Rogelio are working on right now. It's sort of to check so he can show you what a real like living, breathing research thing looks like. Do you want to see what that looks like? Yes, no, who knows? Okay, let's do it. Okay, I see Selena, she's down. Okay, let's go. Okay, so this is again, this is a project. So let's go. So this started last year. This is the University of New Hampshire Carsey School of Public Policy. They have a really well-respected research brief series where they do a lot of demographic and economic research on current population and economic trends in the United States, both regionally and nationally. So last summer, Rogelio and I published a brief there, Inequities of Job Loss and Recovery Amid the COVID Pandemic, where we took a look at patterns of unemployment from February last year through June of last year. And at that time, and COVID was still, I mean, it was before the July spike. It was just still, the unemployment rates were really, really high. And there were a lot of people talking about this, but I think we were some of the first ones to sort of take it and stratify it and start looking at things by race and ethnicity and gender and education and all these different things. And I thought it was a very successful publication. And so they contacted us recently and wanted us to update it. And Aisha had been working on this working from home stuff for a separate analysis. So we asked her to come along and join us on it. And so recently I've been going in and finalizing some of our new plots for the new publication. And each one of these in and of itself is its own sort of use of dplyr and Ggplot chained together to make a simple analysis. But I'm doing it, like we have like 16 plots in the document. So I do like 16 of these separately to make all these different plots. So what we've done here is we get data from the IPUM CPS. If those of you that don't know about IPUMs, you will very soon. IPUMs is a project by the University of Minnesota Population Center. Let them be praised and always be, let them never no rain over their head. Let them always be blessed and highly favored. A wonderful, wonderful group of folks. They take all the census data and process it so it's really easily queryable and usable by people like us. So we get data from here, download a bunch of it, read it in to our my stuff here. The people that make these documents, these things here, they have colors. They have like branded colors that they like. So I made like a little R function here to replicate the colors that they like, so they don't have to go back and remake my colors, remake all of our plots for us. So that's nice of me. And then it's just a bunch of me recoding stuff. I need to make a bunch of because the data are pretty nice, but you can't use them in their pure data form. You have to modify it. You have to do a lot of recoding. You have to do combining of variables and things like that. Like I make a combination of year and month. So I want to index things by time, and CPS is monthly. So you can index it by time by combining year and month together. I do a region variable. I do an education variable because we want to stratify by education some of our analysis. So this is just a lot of recoding of variables, right? Here I do a big mutate step. Again, I showed you this earlier, where I recode a bunch of variables all at the same time. I feed it a data set I do an employment status code, I do a gender code, I do a race code, a Hispanic ethnicity, nativity status, a current employment status, that they recently lost a job, so on and so forth. So I do a bunch of this sort of recoding and combining of data in ways that we want, because we want to eventually slice the analysis by all these different things. The data is a complex survey design that involves population weights. So we have to use survey weighting procedures to take the cases and weight them to their appropriate population totals. So there's a library in R called a survey that will take that does all that for you. Then it goes down here. So here's my figure 1. So this is that nice looking figure that I'm, I liked it when one of our reviewers looked at the figure and was like, I really like this. I felt really proud of myself because I was like, I'm glad you liked that because it was a lot of work. So here's the image. So here's the figure that's produced from this code. So we can kind of walk through what the code's doing and what the figure looks like. Small. Okay. So this first figure is we want to count the number of employed people by month and then make a plot of it. So that's a real simple, group by, summarize, put it in the Ggplot. To make a basic plot, that's all you got to do. So the first thing you got to do, since these are all survey weighted data, you have to use a survey procedure to take the weights into it. And we'll do this a lot in stats too, so don't get freaked out. You take the data that include weights and you weight the data to be the population of adult workers in the United States. Okay, so it goes from a sample of 60,000 each month to a population of 300 million every month. Okay, and I want to slice it this time. I'm going to take it by month and by whether or not you're working or not. So this makes my so we can load this stuff. We can, it might take a second. We'll see. So we load that, and this is going to make a table, like a frequency table of the number of people that are working for each month, okay, which is basically the numbers that go in to make the line. I make sure that R knows that this year month thing is an actual date. Otherwise, it might think it's a number, and I don't want to do that. Then I filtered out to just be the number of people that are working. Again, this is a simple dplyr statement, right? I want to take the total population of workers. I want to filter it to be only those that are currently working, and I want it to be anybody that's, I don't want January of last year. I want to start at February of last year because that's the month right before COVID started. This is all garbage. This is all I've commented out, so it's not doing anything. One thing that we have to do to make this plot, though, is we have to know how many people were employed in February of last year, okay? Because a lot of the analysis that we're doing here is sort of modeling or calculating the recovery. So what fraction of employed people as of last February are working now? That gives you this sort of a currency of how much the economy has recovered since COVID started, okay? And then you can take that and start slicing it into different groups. So if I get February out here, I take all these these workers here, and I just select out the number from February, and I store that as an object. And I need to make these numbers here too. I need to make this line. It's like the pre-pandemic line and the post-pandemic line here, and this link to this line here. I go in here and I can take the number of people working in a given month. Here's February, here's June of this year. The difference is the difference between May and June and February. So I'm doing a lot of calculations, right? I've got all these totals. I can draw parts of them out, take differences between them, because I'm going to use those to make these geometries. Then it's just doing simple dplyr. I take all these numbers, I mutate it so I can calculate the percentage. Then I feed it right into Ggplot. Ggplot, x-axis is month, the y-axis is this change variable. I add a line. That's my blue Carsey branded blue line. It's a little bit fatter than a normal line. Then I add a horizontal line. This horizontal line is going to come from where is that coming from? This one's going to come from the February one. Okay, so this is going to add this dashed line going across here. Then I add a second horizontal line that's going to be the number from June. That's going to make this line go across. Then I make a geometry segment, which is a way to make a little line segment that has 2 endpoints. The endpoints from it are the June number and the February number. And I put arrows on it. So that makes that. Then I do a bunch of annotations, right? I do annotations to add pre-pandemic. I add a annotation that says June 2021. Then I have my labels, my title, my caption, my X and Y axis labels. I make it so that it has a specific theme to it. So it's a real sort of stripped down looking plot, right? It's a minimal plot. There's not a lot of extra goop going on in it. I make the X-axis labels angled at 45 degrees. This is probably my most Googled Ggplot. How do I do that? I swear I do that once a week. I should really write that down. I make my y-axis continuous because these are huge numbers in millions and it's all scientific notation. And then I save it. I make it 8 inches by 10 inches. I give it a nice print quality DPI and you get this. So, the basics of what we just did tonight gets you this, okay? There's a lot of other bells and whistles that I add to this to create little annotations and so I can create differences and things like that. The fundamental part of making this really complicated figure is stuff we just did tonight. And in fact, this is a really simple plot because it's not grouped by anything. It's not colored by any it's not faceted or anything like that. It's a really simple plot. It's just a blue line, right? It's a blue line with nice axes and a couple of other lines added to it, right? So it's not a lot of, it's a pretty plot. But again, the stuff that's going into it, all that foundation we went through tonight. And so, will you start doing this next week? No, you probably won't. This, I've been using R for 20 years, and this is probably the best looking plot I have ever made. So, but each one of these plots, this is the second figure, right? It's the same process. Make a data frame, do some stuff to it, do some calculations, mutate, Ggplot, geoline, labels, captions, and you end up with this plot, right? So this is just a group by, right? I've grouped by this gender here in this case. It's compared men and women across the same time frame on the same axis. So a lot of the stuff that I'm doing in each one of these plots, the code is the exact same. I'm doing the exact same type of plot every single time. I'm just changing some variables that's going into it. So, this first one was a lot of work. The second one was a lot less work because I'm just copying and pasting most of the time. Again, that's why we don't point and click, is I can take all this stuff and, like I've been working with Sarah, I've been working with Simpson a lot recently, and we do a lot of plotting. And, this stuff, this project with Rogelio has given me so much good plot ammunition to use in all these other things I'm doing. I'm glad I put the hard work in. Okay. So I know I've kept y'all longer than I meant to, so I apologize for that. Are there, Scott, Sarah, Sam, we need to talk about anything in the chat?
I think we're good. You can look at it.
I think we covered most things.
Okay, this is where we started. Yeah, color. Yeah. Hadley's either Australian or a Kiwi. So a lot of you can either do it the British spelling of color or the American spelling of color, and they both work. Yeah. See. Yeah, you can say, so Christina, with this scale thing, like here, you can format the numbers. So that's what this scale continuous function here. The scales package has a bunch of different number formatting things into it. So you can make it like this is going to divide everything by 100,000 basically. So that instead of having millions and millions and millions on the scale, it scales it to a million or 100,000. So yeah, there's lots of different ways you can do that. There you go. Or digits. Okay, there's digits. We'll print out a certain number of digits. There's a function, an option called SciPen, SCIPEN, that will change the number of decimal places our displays. Things like that. Although for plotting and stuff, the scales library is really, really, really useful thing. Twitter. Twitter is really, if you follow the rstats hashtag on Twitter, wonderful stuff. Wow. Yeah. I learned, I see so much cool stuff every single day following these really cool R people on Twitter that it's just really remarkable, the stuff that, that's when I think, I've been using R every single day for 20 years and I feel like I know a lot. And then I see people on there and they're just really hitting it out of the park. Just amazing stuff. Yeah. Once you start using it, it's just like everything else. It's like, I'm a crappy driver until I start driving every day. And then I become better because I learn to adapt, right? Same thing with writing code, no matter what you're writing code in. If you start doing it every single day, you start to get a lot better at doing things. Or just like running or playing basketball or playing baseball. It's like anything else, you have to practice. If you don't practice, it's gonna hurt, okay? You gotta stretch. Be sure when you're getting ready to start writing code, you stretch, you do your jumping jacks and things, but you're gonna be sitting down for a while. You don't want that blood to pool in your feet. This vertical bar operator, Lily, is a way to do OR. So let me show you. Close that. So let's go over here, control L. So let's do X is 1 to 10. If else X less than 2 or X greater than 8. 1. Let's do right. It doesn't matter. I spell right. So here I told R if X was less than 2 or if X was greater than 8, that corresponds to X equals 1 or X equals 9 and 10. So this is a way to tell R or. Likewise, the ampersand gets you and. So those are ways, like if you're doing, a lot of times when you do conditional logic, you can do these and or statements to make your conditional logic statements more complicated. But be careful, because if you make a mistake and you think you're doing something, it's always better to go back and check things twice. Other questions? So I had fun. I like to do these things every once in a while that are not necessarily in the textbooks of the stuff you're going to be learning in your classes. So keep an eye out, because I like to do one on GitHub occasionally. I like to do one on other weird R modeling things, stuff like that. So keep an eye out. Follow the folks on Twitter. They're great. Just don't get into the political stuff. The political stuff's a way to lose an afternoon real fast. Just follow our stuff on Twitter. That's the best thing to do. If you have questions, please reach out. I get really excited when you all want to learn stuff. And so if you have a question about something, if you want to see this stuff sort of in the wild, in the research setting, you know, let me know. You'll be doing this all very, very soon. I hope this gives you a little bit of a head start going into your stats classes. You'll be doing this for the next 3 years. So again, it'll hurt at first, but stretch and it'll be okay. I hope this helps some. I'll be sending feedback forms again. So please give me feedback on tonight's lesson. And if you didn't do it last night, please do that. If you want to see different topics, let me know what they are. I do a lot of stuff in R, so we'll make it work. Otherwise, we've run late, so I hope to keep you all too long. But thank you all for your attention. Thank you all for your engagement and your questions. And we'll see you all around the department as soon as we can go back to school. And I'll see you on Zoom otherwise. So have a good evening, and we'll talk to you later.
Thank you.
Thank you.
Thank you.
Bye-bye.
Thank you.
Bye.